Okay, so what we've been finding is the relative or the local extrema, thinking that the graphs that we've been drawing have been having arrows on each end that go on forever and ever, but not all of our graphs do that. Some graphs are given to us in a specific domain, from x equals this to x equals that. So there are things called absolute or global extrema as well. So we can have a graph that looks like this, okay, and once they put dots at the end of it, open or closed, then we have absolutes as well. So this is a relative min, this is a relative max, this is a relative max, this is a relative min. I just put x in and in, and this is a relative max. But there are absolutes also, because this thing does not go on, does not have a range of infinity. Okay, so this is also here your highest value, so this is also your absolute max. And this here is your lowest value, so this is your absolute min. So there's sometimes that absolute will override us saying relative. Okay, it's no longer relative once we make it the absolute, meaning the graph never drops below that value. All right, so that's what we're going to be working on for this last piece, I believe. I believe this is the last piece. Yes. All right, so we're going to identify each labeled point as an absolute maximum or minimum, a relative maximum or minimum, or neither. And then we're going to find the absolute maximum and the absolute minimum of the graph. Okay, so I look at A, and to me, it looks like it's a minimum, but it's not the lowest point on the graph, so it's not absolute. So this to me is a relative min. Looking at letter B, it looks like a maximum. It's reaching a maximum. It's growing and then declining, but it's not the highest point on the graph, so it's not absolute. So this is a relative max. Okay, point C on the graph is a minimum. It's going down and then going back up, and it is also the lowest point on the graph. So this is the absolute min. And point D is the highest y value on the graph, so it is your absolute max. All right, so it's our job now to find out what those minimums and maximums are. Okay, so we know that the x value here at letter A is -1, and we know that the x value here is 2. The way I know that is because it told me those. Okay, but what I can do to find C is I can find the minimum. Okay, so let's go ahead and look at the first derivative, because when the first derivative equals 0, we know we've got a minimum. So when the first derivative is found, you're getting 2x minus 2. We'll set that equal to 0, 2x minus 2. So 2 equals 2x, so that means where x equals 1. And when x equals 1, the original graph at 1 is equal to 1 squared minus 2 times 1, right? Yes? Yes. Okay, so that would be 1 minus 2, that's -1. So it looks like my letter C is at 1, -1, and that is my absolute min. Okay, the other point I want to find is D. Okay, and that's not a maximum point, but it's the absolute maximum point. So truthfully, all I have to do is put in the x value, okay, into my original function. So what is f of 2? So that equals 4 minus 4, which equals 0. So D is going to be 2, 0, and that's going to be my absolute max. So basically the point of this little piece, this little extra video, is to know the difference between the absolute and the relative. The relatives are happening throughout the problem. I'm a little curious here. Are you a little curious how we got this graph out of a quadratic? I'm curious how we got this graph out of a quadratic. I don't think it matches up, but we'll go with it because that was the example that was given. The questioning that we have, right? Okay, so this would answer their question, I'm not sure how we would ever find point B because there is no maximum besides the absolute maximum. In essence, I'm finding that this graph should actually come up like this instead. All right, so keeping that in mind, next week we're going to take a little bit of a diversion from chapter 7, okay? Just a little bit of a warning right off the bat. We're going to, for those of you that like to get ahead, we're going to jump into chapter 14 and do derivatives of trig functions before we go into optimization problems. We want to make sure we can find derivatives of everything before we head into optimization. Optimization is going to be something that a lot of you pull from for your IA, so I want to make sure we can take derivatives of everything before we get in there. So I'm going to have to be real picky about what we go through in 14, knowing that you haven't done optimization yet. So just keep that in mind. It's really, the derivatives of trig is really easy. If you look in your formula packet, there's 3 that we need to know. And they're in the formula packet, so 3 that you need to reference, okay? So hopefully I will see you at the meeting today.